Hi, welcome to a new data science project. In this project, we'll be detecting COVID-19 from chest x-rays. So what are the learning outcomes of this project? In this project, we will learn and understand about image classification using features. We'll learn how to clean and process images for such tasks. We'll learn about convolutional neural networks. And finally, we'll learn how to deploy our model as a Flask web app. So let us see what is image classification first. From birth, us humans have learned to visually identify things around us. We take notice of features in something we are looking at to compare and identify. Let us take a look at a simple example. We are shown two images here, and it is obvious for us that the left-hand side is an image of a car and the right-hand side is an image of a plane. We clearly understand the difference between these two images. But how do we go about understanding which is a car and which is a plane? Firstly, the plane has wings and the car doesn't. The car has four big wheels and the plane has multiple smaller wheels which are sometimes not even visible. They both share having windows and doors, but the shape and structure of these are completely different. These obvious features are helping us identify one from another, right? Now let us take a look at these images shown below. If we are asked to identify which one shows a disease, other than a trained doctor, it will not be obvious to a layman. Thus, machine-aided image classification has seen a rise for some time now. When trained on a lot of data, it can help classifying pictures as and when needed. Be it healthcare, industry tools, etc., it has helped massively. A machine also has the same way of learning, understanding features from known data and then applying its knowledge on newer data, but the features that it learns are very much different from the features that we learn. We shall take a deeper look into this when we look at convolutional neural networks. So before that, let us look at the dataset. The two scans shown before were the scans of a lung from the dataset that I'll be using in this project. The dataset has 8,439 scans of healthy and unhealthy lungs contained in two folders. We have to create a model that will classify each scan in their correct category. The data can be found and downloaded from the link given below. Alright, so before anything else, we'll import some important libraries which will help us in image preprocessing, image reading and plotting, and specifically to create the model and train it. So here we can see that we are loading this function load image to actually read the image, and we are importing this class image data generator which helps us to gather all the data that there is in our directory. So after running that, we're going to set our directory as so and set our batch size, image size and input shape as desired. We are setting an input shape of 128 cross 128 cross 1 since we'll be dealing with grayscale images and we'll be training our model on grayscale images. Then we make an object instance of the class image data generator and we pass these certain parameters. Let us go through them one by one. So the rescale parameter is going to rescale all the pixel values in each image from a range of 0 to 255 to a range of 0 to 1. The shear range and zoom range is basically open to experimentation. Here I'm using it because I was getting a better accuracy. These put spatial transformations to the image to help the model learn features better. Again, horizontal flip is the same. It is a spatial transformation to help the model learn the features better. Finally, we are passing validation split is equal to 0.2. That means out of all the images that we have gathered from the dataset, 80% of them will be put into the training subset and 20% of them will be put into the validation subset. Alright, after creating that instance, we can use the flow from directory function to actually store the images in our dictionary. So the train gen will be storing all the training data. We are passing the function flow from directory the image directory, the target size so that it can automatically resize the images as it reads it, the batch size, the color mode is equal to grayscale, which will automatically change the RGB values to grayscale value. Class mode will be set as binary since there are two classes, and the subset will be set as training. So after running this, we can see that it has found 6,752 images belonging to two classes. Similarly, we are gonna use the same function to create our validation data set. We will be passing the same directory and the same parameters, except the subset will be changed from training to validation. After running this, we can see that we have found 1687 images belonging to two classes. Finally, to get the label values, we can get the label class indexes and then use the key value to list the classes. So we can see at index 0, we have COVID-19 class, and at index 1, we have the non-COVID-19 class. All right. So what are convolutional neural networks? Convolutional neural networks are very similar to ordinary neural networks. They are also made up of neurons. They have learnable weights and biases. Each neuron receives some input, performs a dot product, and has an activation function. The CNNs make forward function more efficient to implement and vastly reduce the number of parameters in the network. Thus, it is a great model for dealing with images. On the left-hand side of the image shown here, we can see a regular three-layer neural network. And on the right-hand side of the image, we can see a convolutional neural network. This convolutional neural network works in 3 dimensions, having width, height, and depth. Each layer of the ConNet transforms the 3D input volume to a 3D output volume of neuron activations. So instead of getting weights and parameters for each pixel, we are dealing with the entire image in volume. Let us look at the layers that make up the CNN. Firstly is an input layer. The input layer will hold the raw pixel values of the image, having the shape, width, height, and depth. Depth is denoting whether the image is an RGB, then it will have a value of 3, or the image is grayscale, then it will have a value of 1. The convolutional layer will compute the output of the neurons that are connected to local regions in the input, each computing a dot product between their weights and a small region they are connected to in the input volume. Basically, it will be using a number of filters with specific sizes to convolve with the image and get features from it. ReLU layer is an activation layer which will apply an element-wise activation function such as the max 0, x thresholding. This basically means that any negative value will be thresholded to 0 and positive values will be kept as is. The pooling layer will perform a downsampling operation along the spatial dimensions, width and height. Fully connected layer will be the last layer connected to this convolutional neural network block. It will compute the class scores as in a regular neural network. Here we can see how a convolutional layer is working. We can see a convolution kernel or one particular filter with a size 3x3, which is convolving with one part of the image and giving us a feature. We can see here how the pooling layer works. The pooling layer basically deals with downsampling the volume spatially. The left-hand side of the image shows us that the volume of 224 x 224 x 64 is being downsampled to 112 x 112 x 64. The depth is kept the same, only the width and height is being cut into half. If we use max pooling with a filter size of 2 x 2 and a stride of 2, it will perform a downsampling of exactly half. We can see on the right hand side a single depth slice where the input image is a 4 x 4 image and a max pool with 2 x 2 filter and stride 2 is applied to get an output image of 2 x 2. What max pool does is it takes the maximum value of the pixels in the region and uses that to downsample. So let us see how we'll be implementing the CNN model and saving it for a web app. We'll be implementing our CNN model using TensorFlow and high-level API Keras. we can access the layers mentioned earlier from TensorFlow and set the hyperparameters ourselves. We'll be adding 4 convolutional layers along with 4 max pooling layers. And finally, we'll have a dense or fully connected layer with 256 neurons. We'll also have an input layer defining the size of the image being fed into the network and an output layer having 1 neuron since it is a binary classification problem. Lastly, we'll save our model and make a Flask app for this project. Now that we are done with image preprocessing and loading the images in our training and testing set, we'll be creating our model. So we'll be importing the sequential class. Since our model will be a linear model, we'll be making an instance of the sequential model. And we are importing all these different layers from keras.layers so that we can use them while creating our block. So we'll be adding the layers with model.add function. Firstly, we add the input layer with the input shape being 128 cross 128 cross 1 as mentioned here. Then we add a convolutional layer with 16 filters, each of size 3 cross 3 and an activation of ReLU. After that, we add a max pooling layer of size 2 cross 2. Then we again add another convolutional layer and max pooling layer with 16 filters, each of size 3 cross 3 and a max pooling size of 2 cross 2. Similarly, we add 2 more convolutional layers and max pooling layers. This time, the convolutional layers having 32 filters, each of size 3 cross 3 and a max pooling being same. After this entire block, we are adding a flatten layer which will flatten the 3D volume to a 1-dimension data which can then be input into our feed-forward neural network for training. Finally, we are having a dense layer having 256 neurons with the activation of ReLU and a dropout layer of 0.2. This means that the 20% of the lowest performing or the lowest contributing neurons will be rejected and will be removed. Finally, we have an output layer with 1 neuron with the activation of sigmoid. Now, we are going to compile the model with the optimizer Adam and the loss being binary cross entropy because our problem is a binary class problem. Let's take a look at the summary of the model. We can see that we have around 311,000 trainable parameters or trainable weights. Finally, we can use model.fit to fit the model and train it on our training data. I have pre-trained this model for a larger number of epochs. Since it takes a lot of time for each epoch, I'm not showing it here. I have added the final 10 epochs here to show the final 10 training steps. We are sending the valgen data set that we created using flow from directory as the validation data in training. The steps per epoch and validation steps are open to experiment for maximizing efficiency and accuracy. So we can see here the final 10 steps or the 10 epochs. We can plot it and see that there has been a steady decrease in the training loss and there has been a steady increase in the training accuracy. Finally, we'll save this model with model.save. Next, we can do some testing using the model that we have created. Here I'm using the pillow library to read the image from the directory. This entire block will also be used in our web app, and we can create a pipeline using this block in our web app. Firstly, we'll be making an empty array with the size 1 cross 128 cross 128 cross 1, and then we'll be opening the path to read the image. Here we are reading a non-COVID, that means a healthy lung scan for testing purposes. We are setting the size as required, and using these two functions, we are reading the image and changing the image from RGB to grayscale and resizing the image to the desired size. Finally, we read the image and store it as a NumPy array, and we reshape it and normalize it by dividing it by 255 so that we can input it to our prediction model. We run the prediction using model.predict and pass the data to it. And then we have a simple if-else statement that if the prediction is equal to 0, that means the class index is 0, then we'll have to predict that it's a COVID-19 class. If the prediction is 1, then we'll predict that there's no COVID-19 detected. So here we can see, since we had given the directory or the image of a non-COVID-19 scan, we can see that our model has predicted the class correctly. All right, so now that we have trained the model and saved it, let us look at how we'll go about creating the web app. I'm going to go to my directory for the app. Whenever we are creating a Flask web app, we need to follow a certain structure in our directory. So the static directory will have any kind of image that we are inputting from index.html. The template directory will have our main index.html file. The app.py script and the model.py script will be in the base directory for the app. Let us open the index.html also. We can see that the index.html file is very small, with the main parts being this form here for inputting the data or inputting the image, this image tag here to show the image that we have input, and this Jinja expression showing the result. We'll look into this a little later in app.py. So let us go to app.py. Since this is the main script dealing with actually making a Flask model, we'll be importing the class Flask to make an instance of the Flask app. We'll be importing a function render template, and we'll be importing a variable request. The function render template deals with rendering our HTML file as and when required, and the request variable will help us to get any kind of data that we have submitted using the form in our HTML file. Another important import is importing the functions from our model.py script. So we can see here that from model, we are importing the functions image pre and predict. If we go to our model.py, we can see that we have two functions, image pre and function predict. So let us go to the app.py first and create an instance of the Flask app. We are setting a directory as so, and setting the allowed extensions to just be PNG, so that only PNG files can be input or submitted in the index.html file. Finally, we're configuring the app to default this directory as the directory for uploading images. Using this code block, we'll be configuring the app to follow this function. It will render the index.html file using render template the first time we land on the web app. Now, using this function, whenever we click the submit button on our index.html file, it will route the URL to use this function here. Let us see what this function does. So using request.methods equal to post, that means when we actually press the submit button in our form here, it will see whether it has received a file or not. So if file1 not in request.files, that means this variable here is the same variable name as shown here in the form. You can see the name here is file1. Make sure this name is matching in app.py as well. If there is no file returned in file1 when we submit the form, it will throw an error that there is no file in the form. Otherwise, it will read the file and store it in our variable file1. We'll be creating a path using the upload directory that we defined here and the input.png, the name of the file that we're going to save. Finally, using that path, we'll save the file that we have read from our index.html. After that, we are sending this path to the image pre function in our model.py. So let's see what it does. In our model.py, we are importing the important libraries that we need to load the model and then test it. We are setting the base directory where our model exists, and we are reading the model using keras.models.loadModel. In the function image pre, we are passing the variable path. Again, as seen in the Jupyter notebook, this is the same code block here. We'll be creating an empty NumPy array with the shape 1 cross 128 cross 128 cross 1. We'll be setting the size and then after reading the image, we'll be changing it to grayscale and then resizing it to our desired size. Finally, we'll be storing the image as a NumPy array and reshaping the NumPy array in the particular shape that we desire and normalizing it. Finally, we return this data to app.py. That data returned is stored in the variable data, and then we can send this variable to the predict function in model.py using this line. Let us see what predict function does. It gets the data here and just uses model.predict and sends the prediction to app.py. Again, we are using a simple if-else statement as seen in the Jupyter notebook. If s is equal to 1, then the result will be no COVID detected. Otherwise, the result will be COVID detected. Now, finally, we are using render template to render our index.html file with whatever changes we have made here. And we are sending this result, which is defined here, to the result variable in our index.html file, which is mentioned here in these Jinja braces. Make sure that this name and this variable name here are same, otherwise it will not read the value correctly. So finally, we are going to run the app using this code block. So now that we know how to create the Flask web app, let us run it and see it's working in real time. We'll wait for it to load the model. All right, so the web app is active on this link. Let us copy it and go to our browser. Paste it here. Okay, so let us not be concerned with this image here. This was already input because I did some previous testing. Let us choose a new file. So we'll be choosing a file from the same dataset that we used to train the model on. Let us go to COVID-19 folder and choose any random image. Let us choose this. So it should ideally predict that this scan shows that there is presence of COVID-19. Let's submit this. All right, so it has correctly predicted that COVID has been detected. Now let us choose another file from the healthy folder or non-COVID-19 folder. We'll choose any file randomly, open it. This should predict that there's no COVID, and it has predicted it correctly.